As I mentioned before, the mean doesn't ever tell the whole story. Certainly, it tells us the middle, or some semblance of the middle. However, as we've seen, it also is important to take a look at the spread of the data, which is where a standard deviation is going to come in. So you're going to see two formulas here. You see a formula for the variance and you see a formula for the standard deviation. We're going to focus obviously more on the standard deviation, but you find the variance to find the standard deviation. So the formula that you will be given is going to look like the top one, but you will see it as the square root of the sum of x squared p of x minus mu squared. So again, really focus in on what this formula says. Square root, which is pretty self-explanatory. That symbol is representing the sum. This is asking you to find x squared, multiply it times the probability, and then find the sum. And then minus the mean squared. So again, not a formula you have to have memorized. I'm going to have a table for you, as you're going to see in a few minutes. Okay. All right. So if we're going to talk about variation, then that also brings back up the range rule of thumb. So remember, significantly high is if your standard deviation, there's your symbol for standard deviation, is more than 2. Okay. Anything more than 2 standard deviations away. Or if your standard deviation is less than -2. Okay. Actually, let me rephrase that. It's actually not standard deviations. It is your z-scores. But it also is anything more than 2 standard deviations away from the mean is going to be significantly high or low. There is also a way to deal with it with probabilities, and that is more or less than 5%. So if you're in the bottom 5%, you're considered significantly low. If you're in the top 5%, you're considered significantly high, which would be like the 95th percentile. Okay, so let's take a look at actually some of the examples that we have already seen. So this is a kind of revisiting the whole idea of the passive aggressive traits that we had seen before. And if you remember, we had gone through and found the mean, which was the sum of x p of x, which was the sum of this middle column here. So our mean was 2.94. I'm going to label that mean. And that's what's going to go right here in my formula. So as we develop this, be really conscious of the table headings. All right, so x squared is going to be this column squared. So I'm just going to go ahead and do 1 squared is 1, 2 squared is 4, 3 squared, 4 squared, and 5 squared. Okay, then because in my formula, I want the sum of x squared p of x, that's where this last column comes into place. However, I can tell you that this is also the place where most people make their errors because they multiply the wrong columns. It is not columns that are next to each other this time. You want x squared with p of x. So you are multiplying those two columns. So I'm doing 1 times 0.16. But then I'm doing 4 times the 0.22. It's really, really easy to do 4 times 0.44. You don't want to do that. 9 times 0.28, which is 2.52. 16 times 0.20, and 25 times 0.14. Okay, so I got those values, and because of the formula, I want the sum of that column, so I'm going to add all of those numbers together to get 10.26. All right, now I'm going to come down to my standard deviation. So my standard deviation is going to be the square root of the sum of the x squared p of x, which is 10.26, minus the mean squared. Now, this is going to be very, very important for you to practice putting into your calculator because every calculator is different. Some of you are going to be able to just type it in as is. It's all going to be great. Others are going to have to type in and then hit the square root later. Again, you've got to play around to see how it works out. You should be getting a standard deviation of 1.27. So keep playing around with that calculator until you get that value. All right, significantly high and low then to determine that. Significantly low is going to be 2 standard deviations below the mean. So the mean was 2.94, and I want to subtract 2 standard deviations. So 2.94 minus 2 times 1.27 gives me 0.4. So any number of any score below 0.4 would be significantly low. And then if I go significantly high, it's 2 standard deviations above the mean. So is 5.48. So that's the score only went to 5. But if for some reason we had more, any score above 5.48 would be significantly high. Okay. All right. So again, really stop and take a look at where all this is coming from. This is, I guess, one of the advantages to this being a digital or video lesson. Okay. All right. I'm going to move on to my last example here, which is going back to the number of trips example that we had talked about previously. So, number of trips, again, you need to remember that mu is the sum of x p of x. And again, I very, very strongly suggest that you just kind of pause the video and work your way through this example yourself, just to get some practice with it. All right, so with that in mind, if I sum this column, I'm going to get the 1.23 as my mean. Okay, x squared. So 0 squared is 0. That doesn't look like a 0. It looks like a 1. 1 squared, 2 squared, 3, and 4. I don't need the sum because that's not part of any formula. But now x squared p of x, remember you're multiplying those columns. So 0 times 0.06, 1 times 0.70, 4 times 0.20. Make sure you're going to the right column. 9 times 0.03. And then 16 times 0.01. I'm going to go ahead and get the sum because I need that as part of my formula. If I add those numbers up, I get 1.93. Okay, off to my calculation. So my standard deviation is the square root of the sum of x squared p of x, which is 1.93, minus the mean squared. So let's do that on the calculator. If I round it, I'm going with 0.65. Okay, then significantly low is the mean minus 2 standard deviations. You do need to know this, that's how you figure that up calculation, which is negative 0.07. So there's nothing significantly low, okay? Because we're saying any number of trips less than a negative. So we're good on the low end. Significantly high would be anything more than 2 above the mean. Which, let's see, 1.23 plus 2 times, gives me 2.53. So any number of trips more than 2.53 is significantly high. So Significantly high would be, in this case, 3 or 4 trips of 5 nights or more. Okay. If you're following along on my spreadsheet, you're going to see that there is some additional information on expected value, but because of our extenuating circumstances this time around, I am actually going to skip that. So this does finish up section 5.1. We'll hopefully be back in class next time, and if you have any questions, then at that point, you can hopefully get them taken care of. All right, have a great day.